All right, so we've been introduced to photosynthesis. It's the process that autotrophs and plants use to create their glucose, and the glucose used to charge ATP, ATP being the molecule that we provides pretty much all the energy that our cells and likewise we live off of. So today we're going to talk more about what actually happens within photosynthesis. And it occurs, especially in plants, in chloroplasts. So if you remember, that's one of the membrane-bound organelles in plants. We obviously don't have them. We're not autotrophs. We don't use them, but they do. Um, and then they're pretty complex organelles. They have within them what are called thylakoids. They're almost like an organelle within inside the chloroplast. And they're these little sacs, and they contain within them all the pigments. All right, for instance, the chlorophyll or any of the other pigments. And then they contain with them all the other enzymes and all the other materials needed to power and charge up and to make photosynthesis happen ultimately, or at least most of it. So in this picture here, the chloroplast is this whole thing, whereas the thylakoid is just one of those, or one of those, and so on and so forth. If you can notice, there's many, many thylakoids inside just one chloroplast, and you can see another chloroplast nearby. There's one over here, there's one over there, all containing dozens upon dozens upon dozens of thylakoids. So really, photosynthesis, to make this as simple as possible, is a two-part process. There is the light reaction, which is to some degree the first reaction, and this takes place in the thylakoids, and it requires light, so hence the name, the light reaction. Now, the somewhat poorly named dark reaction is the second of the two processes, and this occurs outside the thylakoids, still within inside the chloroplast, but outside the thylakoids. And it basically requires the materials created in the light reaction. We'll talk more about this in a minute. Now, lesson learned. So I remember when I was a kid, and perhaps I could have studied more than I should have, or did rather. And the teacher put a true and false question. The dark reaction happens at night. And I didn't obviously study well enough, and I said true, and I was wrong, and I lost points. And I don't want you to make the same mistake. So the dark reaction does not happen at night. All right. But we'll get to that in a second. So you have on your notes this picture. All right. This is a chloroplast. If you wanted to label this now, you could. This whole thing is a chloroplast, and this is a thylakoid. All right. And this is another cycle we'll talk about in a few minutes. You can see other thylakoids off in the distance, and we'll talk about those in a minute as well. But let's label some of the things. So the light reaction takes place inside the thylakoid, and the dark reaction is this cycle over here we're going to talk about in a minute. And then light is the process that charges the light reaction. Now, I don't want you to label these just yet. Don't put these question marks, because we are eventually going to be addressing those. But what I want you to make note of is this question mark right here. Those are the products from the light reaction that are creating a light reaction fed into the dark reaction. And as you can see, the dark reaction basically creates more products that fed back in the light reaction. There's a cycle here we're going to talk about. But these are very important. We're eventually going to get to. So to clarify, all right, the dark reaction does not require darkness. So for instance, the dark reaction won't happen at night. What I mean by that is it doesn't need light directly, and that's kind of why they named it the dark reaction. You'll see more and more people calling it the light-independent reaction, because nowhere within the reaction is light a factor, but because it needs the light reaction, it needs light indirectly. All right, so what I mean by this, well, let's say we bring in the sun, the light reaction starts, and it creates these products which start up the dark reaction. All right, so again, nowhere is light a factor in the dark reaction here, but it is a factor in the light reaction, which creates this, what we're just going to call now products that are used in the dark reaction. And if you take away the light, the light reaction stops. No longer are those products being created, and the dark reaction will stop because of it. And that's what happens at night. So plants kind of sleep to some degree, kind of like we do. All right, once the sun rises in the morning, that light reaction starts back up, and the dark reaction follows in suit, and photosynthesis happens during the day, and so on and so forth. All right, so let's kind of go over try to simplify this again. So we've labeled it so far. The light reaction feeds into light feeds into the light reaction of the thylakoids, all of which of this is occurring inside the chloroplast. And then there's a dark reaction here that's happening outside the thylakoids, but still inside the chloroplast, and then these products. So if you remember some of the reactants and products of photosynthesis. So photosynthesis uses carbon dioxide and water. It creates glucose and oxygen. So the water is actually used in the light reaction. All right. So light actually hits the thylakoid, and they start to consume water, the same water that you'd water a plant with. And then what it provides for us is oxygen. So the oxygen that you breathe has actually been created within the thylakoids of the chloroplasts of the plants and the other autotrophs. CO2 is actually used in the dark reaction. And then ultimately what the dark reaction provides is the whole reason why photosynthesis occurs is glucose. C6H12O6. Another name you may want to write down for the dark reaction is called the Calvin cycle. Often the terms used interchangeably. Or, like I said before, it's also called the light independent reaction, where for the most part it's just a light reaction or a light dependent reaction. Now, we mentioned the products. Those products are ATP. The very same ATP that we're going to be creating from glucose is actually used up a little bit in the process of photosynthesis. And then there's another molecule called NADPH. Don't worry about what it stands for, but it's this very important molecule that carries, it's used as a reactant in the dark reaction, both that and ATP. And without the light reaction, these wouldn't be created. And without these, you can't power the dark reaction. So going back, light powers the light reaction, which creates these, which powers the dark reaction. Now, the dark reaction does break these down, which feeds back into the light reaction. So it takes the ATP, turns it back into its lesser form, if you remember, ADP. And then it takes the NADPH and turns it into its lesser form, which is NADP+. All right, which are fed into light reaction, which are used. And there's a cycle within here, too, that's very important. So you could argue that the light reaction needs the dark reaction, too, because the dark reaction creates these that feed back into the light reaction, and so on and so forth. Now, if you ever take higher level biology, there's a lot going on in here. It's not this simple. But as far as what I want you to understand at this point, I really want you to understand this. And more importantly than anything else is where the reactants are used, where the products are created, the relationship between the light and the dark reaction, the general anatomy of a chloroplast. That's really what I need you to take away from this level of understanding for photosynthesis.